Alright, so this is really 11.1 a little bit and 11.2, mostly 11.2, but there were a couple things on Friday that we didn't get to in 11.1 that I wanted to talk about. So let me get a pen up here. Where are my pen tools? Okay, hold on. Okay, sorry about that. I was having trouble finding my pen tools. I think I'm going to try green. So when you're converting from degrees to radians, there's two ways to go. You can either go from degrees to radians. So if you notice, all of these problems are given in degrees, and we want to convert to radians. So you would go the degrees to radians route. Okay, degrees to radians. I didn't mean to cross that out. And I don't like this formula. I like this one better. So we're going to go with this one. And we're going to multiply by pi radians over 180. So we're going to take the 240 degrees and we're going to multiply it by pi, and you don't need to write the word radians, over 180. Okay, so I can reduce this using my brain. How many times is what goes into both 240 and 180, and 10 goes into both of them, so those could cancel. And then what goes into 24 and 18, and 6 goes into both of those evenly, right? So 6 goes into 24 4 times, and 18 3 times, so the degrees cancel, so it's 4 pi over 3. Now I'm going to show you how to do that on your calculator. So to do it on your calculator, you're going to do 240 divided by 180. And you're going to get this weird decimal, 1.33333333. Well, some of you might recognize that as 4/3, but again, I'm going to show you how to use the fraction button on the calculator. So with the 1.3333 showing on your screen, hit the math button, and then option 1 is frac. So just enter frac, and on the screen it say answer frac. Then hit enter one more time, and you're going to get 4/3, and then you just tack on a pi at the end. So it's 4 pi over 3. Oh, crud, is the answer. So, sorry about that. Let's go over here and clean that up a bit. So my answer again was 4 pi over 3. Okay, so I'm going to ask that the sub pause these while you try 150, 30, and 90. So I'm not actually going to stop and wait because that just makes the recording way too long, but I'm going to ask that the sub shut it off or pause this, give you some time to try it, and then when you're ready, let him know or her know, and we'll start it back up. Okay. So the sub is restarted, hopefully, and we're going to go over these again. So remember, you just multiply by pi over 180. So I'm going to put this over 1, and we're just going to multiply. And the degrees cancel. And then, again, you can use a calculator, or you can divide. I'm going to go ahead and divide. 10 goes into both of those, so 150 divided by 10 is just 15, and 180 divided by 10 is just 18. And then 3 goes into both of those, so 15 divided by 3 is 5, and 18 divided by 3 is 6. So this would be 5 pi over 6. And then again, using your calculator, you could just do 150 divided by 180, and you get a decimal, 0.83333. Then you just hit math, frac, enter again, and you get 5/6, and you just tack on a pi, so 5 pi over 6. Okay, 30, on Friday I went over this lesson with you, and I showed you that 30 was actually, we asked how many times 30 went into 180, and 30 goes into 186 times, and 180 is pi, so 30 should be pi over 6. but let me show you how you would get it using the calculation. You're going to multiply by pi over 180. Again, we're going to cancel out the degrees. 10 goes into both of those, so I get 3 over 18, and then 3 goes into both of those. 3 goes into 3 once, and 3 goes into 18 6 times, and again I get pi over 6. And if you want to use a calculator, you're going to do 30 divided by 180, math, frac, and it's going to give you pi over 6. So this answer was 5 pi over 6, and this answer was pi over 6. And then just thinking about it, remember I sort of talked about this before. This is 0, this is pi, and 2 pi if you go all the way around. So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, it keeps going like that. 90 is between 0 and pi. Remember, pi is just 180. So between 0 and 180 is 90, so this right here is 90. But if this is pi, this is half of pi, so pi over 2. But again, if I want to just go ahead and multiply by the formula, it's pi times 180. The degrees cancel. And then how many times is 90 go into 180? Twice. So again with a pi over 2 in radians. Okay, now if you mean degrees, you have to put degrees. So if you're saying 90 degrees, you have to write the degree sign. If you're talking about radians, you can just write pi over 2, and everybody understands that you're talking about radians. So unless it specifies degrees, when you get on to the more advanced maths, once you unless it specifies degrees, then it's understood that you're talking about radians. Okay, so that's good. Okay, so again, this was page 317 in your planner. Okay, I guess it would have been nice if I'd started it with that, but I didn't, so oh well. Okay, so here we go to the next slide. So this time we're going to convert from radians to degrees. So if you notice, all these has pi's in them, so these are definitely radians. So we're going from radians to degrees. And again, I don't like this formula. We're going to use this one, 180 over pi. So to do this, you just multiply by 180 over pi, and you don't need to put the radians. So here the pi's cancel, and you're just left with 180 divided by 3. So on your calculator, you can do 180 divided by 3, and you would get 60 degrees. So this answer is 60 degrees. Okay, so I'm going to ask that the sub pause this, and I want you guys to try the next 3. So again, I'm not really going to pause. I'm just going to ask that the sub pause it, and I'm going to keep going. That way when you pick it up, I'll be right where I left off. Okay, so hopefully the sub paused and you're back with me. So to convert this, we're going to multiply by 180 over pi. So again, the pi's cancel. And then I can do 6 goes into 180. 6 times 30 gives me 180, so that would be 30 times. And then I'm left with 5, so 5 times 30, which is 150 degrees. And I'm sorry, this should say 180 degrees, so we get our degrees. Okay. Again, calculator wise, you could just do this. On the calculator, we would type in 5 times 180 divided by 6, and then it's going to give you 150. Now, if it gave you a decimal, then you could do frac and get the fraction, but it's okay to actually get a decimal. Okay, so let's try this one. So again, we're going to multiply by 180 degrees over pi. The pi's are going to cancel. And I know that 2 goes into 180 90 times, so that means 4 must go into 180 45 times, so that'd be 45. And then 3 times 45, so 3 times 45 would be what, 120 plus 15, so I believe 135. But let's just double check that on the calculator. So on a calculator, I would do 3 times 180 divided by 4. And I definitely get 135 degrees, so that's good. Okay, and then this one we already know. Hopefully you remember when we talked about it. Remember, this is 0 and this is 180, and all the way around was 2 pi, and halfway around then would be pi. So this better be 180, but if I go ahead and multiply by 180 over pi, the pi's cancel, and I'm left with just 180. Okay, so again, you know, radians, we're not really going too in depth with it, but when you hit pre-calculus, and again next year when you take algebra 2, and then definitely in calculus, you're going to be talking about angles almost all the time in terms of radians and not in terms of degrees. So it's kind of like learning to count to 10 in Spanish. Okay, probably even if Spanish is not your first language, everybody knows how to count from 1 to 10 in Spanish. So if I say, and you're going to laugh at my accent, but if I say diez in Spanish, everybody knows I'm saying 10, right? If I say uno, everybody knows I'm saying 1. So we want you to get to the point when I say pi over 2, you're all thinking, oh, that's 90 degrees. Or pi over 4, oh yeah, that's 45 degrees. So we're hoping that, you know, by the time you get to calculus, if we go over this enough, you'll start thinking about angles in terms of radians. But again, you know, just baby steps. So all we're doing with them today is just converting them. Later we're going to learn how to make calculations with them, but it really does make calculating with radians is a lot easier than calculating with degrees, and that's why we have this thing called a radian. Okay. Okay, so the next slide. Okay, so this is on page 320, and this is 11-2. So we went from, I think, page 317 before to now page 320, and here's the definition of population density. And I want you to actually write this formula down too. The population density is the number of people divided by the area of the land. Okay, so like for instance, Montana is a much bigger state than, say, New York. But New York has a greater population density because more people live per square mile than they do in, say, Wyoming. Or, sorry, I was talking about Montana. So Montana is like the 4th largest state. New York, I don't know, but it's not very big at all. It's probably not even maybe a quarter of the size of Montana. The biggest state is actually Alaska, and their population density is very, very small, and so the number of people per square mile is very, very small. Whereas the tiniest state, Rhode Island, has a great population density, right? So a lot of people live in every square mile. Okay, and again, like the city of San Francisco has a much greater population density than the city of Oakley. Okay, so that's population density. Okay, the area of a sector is a piece of the pie or a piece of pizza. So I'll color it in this area right in here is a sector. So if I were to cut that out and just look at it, so I had something that looked like this, it would be a piece of pizza or a piece of pie. Okay, so the actual definition is a region of a circle bounded by two radii and the edge of a circle. But what I want you to get out of that is this drawing. So I'm going to give you just a second to draw it. Again, remember, have the sub stop when you need to write something down, and then pause it on your own. Also, my pre-calculus students watch this on their phones in their earbuds while the lesson's going on, so that's fine with me as long as it's okay with your sub, but you actually have to be doing this and not playing with your phones. If you don't already have a calculator, I'm leaving directions for the sub for you to get a calculator. So, just get a calculator, make sure that all 30 calculators are back at the end of the day. But you are going to definitely want to use a calculator for today's lesson, so you should have a calculator out as well. Okay. And Antoine, oh, never mind. Okay. Wrong period. Sorry. Okay, moving on. Okay, now this slide is not in your journal, so I just want you to really watch this. I don't really want you to do this. So nobody really has to write this down. I just want you to remember that area is the number of squares of a certain size that fit into a shape. Okay, so here we have an example. So here I have a circle, and if I wanted to find the area of the circle, I'd find out how many squares fit into this circle, right? So I could count up all the squares, but that's a lot of squares. So I divided the circle into fours, and I'm just looking at this wedge right here. Okay, and then I'm counting these. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, those are all, well, not 28 or 19, but 9, 14, 20, 5, and 2, and then all these other ones are full squares. So we know for sure that those are 1 square each, right? And then I looked at this and I said, okay, well, if I look at 1, I am missing a little bit of 1, but I get most of it, so I'm going to go ahead and keep that as one whole thing. And then I said, okay, these two together look like they will be another square, so 25. And then actually I included this little bit in here with the 1 over there. And then 26 and 27, I said they were mostly full. And then these two together make you 28, and basically I came up with that. So roughly it looks like the biggest number I got here was 28. So now you can't count exactly. If this was a rectangle, I could count exactly how many squares were in it, right? But for a circle, you got to do some estimating. So I'm saying the area is roughly 28 degrees. Or not 28 degrees, 28 square units. Okay, now we haven't really talked about this, but the area of a circle, remember circumference was d pi or 2 pi r. Area is pi r squared. So if I look at this radius is 1, 2, 3, 4, 5, 6. So my radius is actually 6. So my area of the whole circle is pi 6 squared. So pi 6 squared, which is 36 pi. Now I forgot to make a calculation over here. the area of just this quarter of the circle is about 28. So the area of the full circle should be 28 times 4. And 28 times 4, if you use your calculator, is going to be about 112. So this is about 112 units squared. Okay. So well, let's see what 36 times pi is. So remember, I'm going to use the pi button on my calculator. So 36 times the pi button on my calculator is roughly 113 units squared. So this calculation was pretty close. Okay, so by just counting, I came fairly close to the amount of units that the area is. So I just wanted to recap what area actually means. So remember, area is the number of squares of a certain size that fit into a circle. Okay. So moving on to the next slide. Here's the formula for the area of a circle. Area equals pi r squared. And like I said, we just went over that, so that's it. Okay, and we're on page 220 now, if you didn't notice. So this slide isn't your journal, so I want you to just use the formula to find the area. Oh, and we already did this. It was 1, 2, 3, 4, 5, 6. So we did A equals pi times 6 squared. So I get 36 pi for my exact answer. And 113.1 basically for my approximate answer. Okay, so I don't know why that slide's in here, but that's what it is. Oh, no. Cool. Hold on. Yeah, this is right. Okay. So now this next side, we're just talking about the sector. So because the sector formula is coming up. So remember, we already counted this, but in the sector, we figured it out that there was about 28 units squared by counting these up, right? Now this is just in this sector, so we're talking about just in this piece of the pizza. Okay, so that's about 28 square units. So let's look at the formula for the area of a sector, and then we'll figure out exactly what it is. Okay, so there's these two formulas here. I don't like this one at all. I like this one, this bottom one. The area of a sector is the measure of the arc. So this is just like, remember the arc length formula was the measure of the arc over 360 times 2 pi r. And remember, 2 pi r is just the formula for the circumference of a circle, right? And here the difference is this part's the same, but it's pi r squared. And remember, pi r squared is just the area of the circle. Okay, so this is a formula that we're going to use. And we're going to try it with this other one. So move on. And again, if you need time, ask the sub to pause it, please. And then I'll just stop, and then it'll pick back up where you left off. It's pretty easy, so I'm going to tell the sub to be watching for you to ask to pause it, but go ahead and pause. Okay, so again, this slide's not in your journal, but using the formula, what's the area of the sector? So again, we've counted this a number of times. This radius is what? Yes, 6. So I know that my radius is 6. And this is a 90-degree angle. So if this angle is 90, what is the measure of this arc? Right, the angle is equal to the measure of the arc. So this angle is 90 degrees. So remember, the formula was the arc measure of the arc over 360 times pi r squared. So the measure of my arc was the 90 over 360 times pi times 6 squared. And 6 squared is 36, so I have 90 over 360 times pi times 36. Now, on your calculator, you multiply all the numbers that are on top. So the numbers that are on top are 90 and 36. So you're going to multiply those together. 90 times 36. And you're going to get 3240. Okay, now the number on the bottom is 360. So I'm going to divide by 360, and I'm going to ignore the pi for a second, and I'm going to get 9. And then I'm going to tack on pi. So I'm going to get 9 pi for my exact answer. But now if I approximate that and multiply by the pi button, so 9 times pi, I'm going to get 28.3. And let me just go back a slide. I'll come right back. A couple slides, actually. We said it was going to be 28 units squared, and we got 28.3 square units. So units squared. So this was a pretty good approximation, just counting up the squares, right? But that's not very practical, which is why we go with the formula. Alright, so here some practice problems are, and let's go through them. Okay, so I'm going to ask the sub pause it, and I'm going to give you a second to go ahead and solve this. They're asking you to find the area of circle M. So the sub's going to pause it, you're going to try it. I'm not really going to pause because the sub's going to pause, and now I'm going to start up again. So here we are, we're back, and we're going to say, to find the area of circle M, we know that the formula is A equals pi r squared. So we need the radius. So this 5, do you see how it's right in the middle there, right in the middle? It's actually saying from here to here is 5. So my radius would be half of 5 divided by 2, which is about 2.5. So that's what I'm going to use for my radius. And we're going to give an exact answer and round it to the nearest tenth. So it's going to be pi times 2.5 squared. And I believe that 2.5 squared is 6.25. So I should get 6.25 pi for my exact answer. And we're going to plug into the calculator to check. 22.5 squared. 6.25. Okay, now the approximation, I'm just going to do 6.25 times the pi button on my calculator. And I get 19.6. And this is centimeters, so it would be 19.6 centimeters squared. And again, I'm not a stickler for remembering your units. That looks a little sloppy. Let's try this again. 19.6 centimeters squared. I'm not a stickler for remembering your units, but you know, another teacher in the future might be, so I should talk about units. So area is the number of squares that fit into something, so we use square units. Okay. Now number 2, I'm going to ask that the sub pause, let you give this a try on your own, and then we'll come back and talk about it. Okay, so hopefully the sub has now restarted. I gave you a second and restarted. Again, the area is pi r squared. And this time we know the radius is 7. It just told us the radius straight out. So my area is going to be pi times 7 squared. And 7 squared is definitely 49. So I get 49 pi for my exact answer. And for my inexact answer, when I multiply by the pi button, so 49 times the pi button on my calculator, and I get 153.93. So 153.9 would be my approximate answer. And this is meters, so we should say meters squared. Okay. Number 3. So it looks like we have 8 more problems. Find the area of a circle with a diameter of 1.8 inches. Okay, so again, formula for ask the sub to pause, and you give this one a try on your own. So please pause. Okay, so now we're ready to go. I don't need to draw a picture, but I guess I can. So here's a circle. That's not quite a lovely circle, but that's alright. And we know that the diameter is 1.8. So that means the whole the way across, right? Now again, area is pi r squared. So my radius is 1.8 divided by 2. Because 1.8 is my diameter, so my radius has to be that divided by 2. And I believe that's 0.9. 1.8 divided by 2 should be 0.9. And it is. So now I know that my radius is 0.9 inches. So my area is pi times 0.9. Well, 0.9 squared, sorry, 0.9 squared. 0.9 squared, it'd be 0.9 times 0.9, which would be, I believe, 0.81. But again, we'll just double check it. Squared. Yep, 0.81. So my exact answer would be 0.81 pi. And then my approximation would be 0.81 times the pi button on my calculator. And we get 2.5. And this is inches. So it would be 2.5 square inches. Whoops, 2.5 inches squared. Or you could say 2.5 square inches. Either way of writing is fine, but I think it's easier to say inches squared than the word square inches. Okay. Alright, so I know the next slide, problem number 4. And this time it's asking you to find the diameter of a circle with an area of 10 feet squared. And you know, I think I'm going to do this problem with you to get started. And then you can try another one. So this one we're not going to ask the sub to pause for, but we're going to start out with writing the formula for the area of a circle. Okay, so the area, remember, is pi r squared. Now we don't have a diameter formula, so we have to find the radius first, and then we're going to have to multiply that by 2 to actually find the diameter. Okay, but we're going to plug in what we do know, and what we do know is 10 is the area. The area is 10. So I'm going to replace a with 10. And I'm going to get pi r squared. Now I have to get r squared by itself, and this says pi times r squared. So I'm going to divide both sides by pi. So now I'm left with r squared equals 10 over pi. And at this point, I'm going to go ahead and figure out what 10 divided by pi is on my calculator. So I get r squared equals 10 divided by pi. And I get 3.1830 blah 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 blah, right? Now I'm going to leave that number on my calculator. I'm not going to put clear, I'm not going to do anything, so it'll store it. I'm going to write down close to what it has, but you know, the more accurate answer is if I leave the answer on my calculator and then go on from there. It's 3.183 09 blah blah blah. It sort of keeps going, right? I'm going to leave that number on my calculator. I'm not going to hit clear. Now I have to get r by itself, so how do I undo a square? Yes, I square root. So leaving this number on my calculator so I get it all, I don't have to retype anything. I'm just going to hit the yellow button, the second button, okay, and then the square root button, remember, which is right above the log button, right where it says log. And then I'm going to hit, it's going to say this is what it's showing on my calculator screen. So here's my calculator screen over here. And it had that 3.183 blah 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 blah. And then I did the second square root thing, so now this is on my calculator. Now I want to tell it to just go ahead and find the square root of this answer. Okay, so to do that, I'm going to hit second, so the yellow button, and then answer. So answer is right next to the enter button. So find your enter button. So here's my enter button. Right here is my enter button, and then the button right next to it, right there, that right there says parenthesis minus on the button, right? But above that in yellow it says ANS. So ANNs. So when I hit it, once I hit second answer, then the ants gets put in the screen right here. And then I can go ahead and hit the enter button. That's the enter button. Okay. And I'm going to get an answer. So I'm going to hit enter. And you get 1.78, which would be about 1.8. So R equals about 1.8. And this was feet, but radius are measured not in square feet, but just feet, so it'd be 1.8 feet. Now, if you didn't get that, if you can't do that whole calculator thing part again, then you can just do the square root of 3.18. And the square root of 3.18 is 1.8. So you'll get the same answer. Sometimes you might be off by a tenth or so, so that's why I like to store it in, but you wouldn't be too far off if you found the square root of 3.18. You'll get about 1.8 feet. Okay, but storing it in your calculator is also a little more efficient. So just at 1.83, dot dot dot. And then you just hit the second square root and then second answer buttons and then equals or enter, and you get the 1.8. Okay, so number 5, this time you have to, oh wait, gotta go back, we were wrong. 1.8 is a radius, it was asking me to find the diameter, right? So if I take that number that should still be on my screen, that 1.7832 blah blah blah, and I multiply that by 2, I'm going to get 3.56 or 3.6. So my diameter is the 1.78 blah 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 times 2, and you get 3.6. So 3.6 is diameter. Okay, back to this one. This time they don't want you to find the diameter, they want you to find the radius, but you're still going to work backwards. So I'm going to have the sub pause it and give you a second to solve this on your own. Okay, so hopefully the sub paused and now we've restarted. So again, we're going to write the area formula down. The area is equal to pi r squared. And I know my area is 65. So I'm going to do 65 equals pi r squared. I'm going to divide both sides by pi. And I'm going to get r squared equals 65 divided by pi. So on my calculator, I'm going to do 65 divided by 5, divided by pi, and I'm going to use the pi button. And I'm going to get 20.6901, blah, 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 right? So I'm going to keep that answer stored on my calculator, and then I'm going to say, okay, I have r squared equals 20.69 blah blah blah, so I'm going to take the square root of that. So again, remember to do that, you're going to do second square root and then second answer, enter, and you should get 4.5. So we're going to get r is 4.5 centimeters. And we're talking the radius, not the diameter, so no need to multiply by 2. But again, you know, if you couldn't figure the second answer button on your calculator, just do the square root of 20.69, and you're still going to get 4.5. I know every single time it looks like we're always getting the same answer, but there are some times where we'll be off, and then that will just make us off later on. So it's best to keep these numbers stored in your calculator until the very end. Okay? Number 6, we have to find the area of a circle with a radius of 6.1 yards. Okay, so again, I'm going to ask that the sub pause so you can try it on your own. Okay, so we're back. This time it's straightforward. It's not a working backwards kind of problem. It just wants the area. I've lost my cursor. Oh, there we go. Okay, so I know you guys see this big yellow thing. I only see this really tiny black dot. So what you see isn't what I see, so it's really easy for me to lose my cursor. Okay, but remember area is pi r squared. And my area is what I'm trying to find, and I know that my radius is 6.1. So I'm going to get A equals pi and then 6.1 squared. So on my calculator, I'm going to do 6.1 squared. And that's 37.21. So my exact answer would be 37.21 pi. And my approximate answer, this is exact, my approximate answer would be 37.21 times the actual pi button, and that would be 116.89, so 116.9, and this would be 116.9 yards, and yards is YD squared. Alright, almost done, only 2 problems it looks like. So number 7, it wants us to find the area of this sector. Okay, so we're going to find the area of the sector. Let's write the formula down. Actually, why don't you guys, I'm going to ask that the sub pause it and you try it yourself. Look at the example that we already did. You know, the sub can bring the slideshow back to that slide if you wanted to look at my work again. So that's between you and the sub to decide. Okay, so we're back, and you know, it just occurred to me that I want to remind you that retakes for 7-3 and 7-4 are Thursday and Friday during advisory. So you can ask my sub for a pass from advisory, and then you either go to Miss Rucker's room, which is directly across the hall from me, or Miss Catania's room, which is, you know, the room right next door to me. And they'll give you passes, and that's where you would report during advisory. One of them is going to be doing 7-3, and the other is doing 7-4, and you know, I'm making this before I'm gone, so I don't know who's doing what, so I'll let you know. I'll have it on the board so you can check, okay, along with their room numbers. But you want to be there like right as soon as you can after advisory starts. So you want to make sure you get the pass before advisory. So like on today or on Wednesday, you want to have the pass. Or Thursday morning, you can run into Miss Rucker's room. She's there early in the morning. Run into Miss Rucker's, ask for a pass, and then you can report to whichever room you need to during advisory. You got to go to your advisory teacher and check in, and then you can run to the class. Okay. But let's go ahead and do this. So remember, the formula for the area of the circle was the arc measure, so the measure of the arc over 360 times the area formula, and the area formula is just 2 pi r. So this is the area of sector formula. So this doesn't say mark, it says the measure of the arc. My brother-in-law spells it that way actually. He's Mark, M-A-R-C. That's funny. Okay, so the measure of the arc, so the angle is 140, so that means the arc is 140. And the radius is 4. So we want to find the area of the shaded region here, so I'm going to do 140 over 360 times 2 pi r. Oh, crap. I don't know if you caught me. I made a mistake. What was my mistake? Yeah. 2 pi r is for circumference, or arc length, and we want area. So I am so sorry, but this should have been pi r squared. So pi, and then my r is 4, so 4 squared. So that looks like 140 times pi times 16 over 360. So the numbers that are on top are 140 and 16, and we're going to tack the pi on, and we're going to divide by 360. So 140 times 16 and I get 2240, and then I'm just going to go ahead and divide by 360, and I'm going to get 6.2222. So my exact answer would be 6.2 pi. Okay, but leaving that 6.2222 on the screen, I can just say times the pi button on my calculator, and I'm going to get 19.5. So my area will be 19.5, and that looks like centimeters squared. So if this was a piece of pizza, I'd be eating 19.5 centimeters worth of pizza dough, cheese, tomato sauce, and whatever toppings you like. Are you hungry? Okay. And the last problem, problem number 8. Again, we have to find the area of another circle. Oh, I think there might be one more problem after this, so bear with me. So the area of this sector, so you guys give this a shot. I'm going to ask the sub to pause, and then we're going to come back and we're going to go over it again. Still pausing. Okay, so hopefully they paused and we're back. So again, the area of a sector, so area of sector should be the measure of the arc over 360 times pi r squared. And this time, oh no, it wants us to find the area of circle Y. Ooh. Well, to find the area of circle Y, we need r, right? And it doesn't look like we have r, so we're going to have to work backwards to find r, and then we're going to have to use whatever r we get when we find the actual area of a circle. Okay? Actually, there's another way. Let's try this way, and then maybe I'll discuss the other way with you. This way is actually the harder of the two ways, but maybe a little more straightforward for you to think of. So I know the area is 4.1, and that equals the measure of the arc, which I also know, and that was 25 over 360 times pi r squared. Well, pi r squared is actually the area. That's what we're looking for. This is the area of the circle. So we don't really need to find r. We just have to get pi r squared by itself, right? So I'm going to put this over 1, and I'm going to cross multiply these. I'm going to leave the pi r squared where it is, but when I cross multiply, I get 1 times 25, and then 4.1 times 360. And actually, this is easier than the other way I was thinking. But I'm going to get 1.25. We're not going to leave the pi r squared where it is. I have to do 1 times 25 pi r squared. So 1 times 25 pi r squared is going to be 25 pi r squared. And that's going to equal 4.1 times 360. And the 4.1 times 360 is 1476. And then I'm going to divide both sides by 25. Pi by 25 and pi. So I'm going to do, now 25 is on the bottom and so is pi, so this is a tricky calculation. You could do this, you could do 1476 divided by 25 times pi, so 25 times pi on your calculator is 78.5398 blah blah blah. And then you could do 1476 divided by second answer. Let me write down this. It was 78.5398, blah, blah, blah. Okay. Or you could do 1476 divided by 25, and since the pi is on the bottom, we have to also divide by pi. So you do 1476 divided by 25 equals, and then divide by pi, and we should get the same answer. So okay, wait a second. 25 pi. $18.7, or I could do, I'm sorry, I had a calculator issue. Okay, so I'm getting, I think, 18.8. Let me check the other way and make sure. Yeah, 18.79, so 18.8. So my area of just that sector, oh crap, I did it wrong. Oh yeah, I'm sorry. Okay, I was right to a point and then I got wrong. So when I multiplied, I should get 25 pi r squared equals that 1476. And I don't want to divide by pi because pi is actually part of the area formula. So I didn't want to divide by pi, I just wanted to divide by 25. So if I do 1476 divide by 25, and again, I really apologize, I'm going to get 59.04. Okay, so my answer should be 59.04 feet squared. Now, another way to think about it is that this is 25 degrees of the circle, right? And there are 360 degrees in a circle. So if I do 25 divided by 360, or 25, let's do divide by 360 and then fraction, I get 570 seconds. So this is 570 seconds if I reduce it. So I know that 4.1 is 570 seconds of the area of the circle. So if I let A equal area, and I get that. So I'm going to multiply by the reciprocal, which is 72 fifths. So 4.1 times 72 divided by 5. And I get the same answer, the 59.04 feet squared. So that's the other way that you can do it. But again, you know, just cross multiplying here. One more way, just it's the same way but without the cross multiplication. When I got the 4.1 equals 25 over 360 times pi r squared, I could have just multiplied both sides by the reciprocal, 360 over 25, and 360 over 25 here. And then these would have canceled, and I would have gotten pi r squared equals that 59.04. Alright. Let's see if there's one more slide. I can't remember. Okay, so now we're going to use that formula that we looked at for at the beginning, and let's go back and take a look at that formula quick. I think I need to. There we go. So it's the number of people divided by the area of the land. So the density is the number of people divided by the area of the land. So number of people divided by the area of the land. And I think if I do this, I can get to the one I wanted. Maybe a little bit easier. Good. So the density is equal to the number of people divided by the area of the land. So we know that about 70,000 people 70,000 people live in a region with a 30-mile radius. So I'm going to do 70,000 divided by 30 to get my population density. And I get 70,000 divided by 30. And I get 2,333. Is 2,333 people per square mile. So just to give you an idea of what that is, hold on a second, I'm going to pause and Google something really quick so we can compare that so we know if that's a lot or not. Okay, so I'm fresh done with looking at some Google. It's a little confusing, but it looks like the population density of Oakley is about 2,000 also. So this would be a region a little bit like Oakley. Whereas a place like New York has a population density of 27,000 per square mile. Now Tokyo's is really weird the way they calculate it, so it looks less, but Tokyo definitely has the biggest population density. I was just looking at some research on that. Over 2 million people work in Tokyo but don't live there, so over 2 million people have to commute to Tokyo every day. That just seems insane to me that there's that many people commuting in a day to one city. It'd be interesting to look at the other cities. Okay, well anyway, so this is not a huge city. Something like San Francisco is much bigger. And then I think the largest one was, I think in India. I can't remember. I was looking, but I didn't write it down. Okay, so I think that's the end. So I hope you've been good for the sub. Yep, that's it. And don't forget to get the slips from either Miss Rucker or Miss Catania. And don't forget, our test is on Friday. Oh no, for you guys it's on Monday. Okay.